So question number 19 looks like this. It says factor the trinomial 9r to the second plus 15r plus 4. Now, this is a trinomial. Again, our first step is to try and find a common factor. But 9, 15, and 4 don't have anything that, except for 1, we don't count 1 when we're doing this as a common factor. We only want numbers larger than 1. Also, the r's are only in 2 of the terms. It's not in the third term. So there is no common factor. Again, 1 is a common factor, but that wouldn't help us with anything. So since my leading coefficient is a number other than 1, it doesn't just start r squared, but it starts 9r squared, we use what we call the AC method. We multiply the A and the C, and that gives us a positive 36. Now, what we're going to use is the 36 together with the middle term, the 15. What we're looking for is 2 numbers, since this is positive, that will multiply to positive 36. So either it's going to be 2 positives or 2 negatives. Since the middle term is positive, it must be that they're both positive. So we're going to have 2 positive numbers that are going to multiply to 36. But when I add them, because this is a plus, so where we have to add them, they're going to give me 15. So let's think of what multiplies to 36. Obviously, 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. There are a lot of combinations of numbers that multiply to 36. But we want them to add to 15, and the only ones that add up to 15 are the 3 and the 12. So I rewrite this trinomial into 4 terms where I bring down the 9r squared. I break up the 15r into 3r and 12r, and I bring down the 4. I do this so I can use grouping. And in my first group, I see a common factor. First of all, 3 and 9 and 3 give me a common factor of 3. R squared and r give me a common factor of r. So 3r is my common factor. 3 into 9 is 3. R into r squared is r. 3 into 3 cancels. R into r cancels. Remember, if everything cancels out, it means it's a 1. So my first group is 3r parentheses 3r plus 1. I go to my second group. It's plus 12r plus 4. So between 12 and 4, we have a common factor of 4. And it's positive because this middle term is positive. But there's no r as a common factor. 4 into 12 is 3. So this gives us 3r. And 4 into 4 again gives me 1. And I see that my binomial factor, common binomial factor, is the 3r plus 1. So that's 1 parentheses. The other parentheses are what we see on the outside, which is the 3r and the plus 4. Don't forget, when you start that second group, that you put either a plus or a minus. And there always has to be a number outside. If the only common factor is 1, in this case, you would put the common factor of 1 because you want to see what's outside each of those parentheses. And this would be your answer, 3r plus 1 and 3r plus 4. That was question number 19. Okay, so going on, unless there's a question, going on with this, we're going to go on now to question number 24. Number 24 is this. We have 25m squared minus 20m plus 4. And we want to factor that again completely. Now I look at it. Is there a common factor? Well, there's a 25, a 20, and a 4, so nothing goes into all of those. And m squared and m, there's no m over here. There is no common factor. So again, we're going to have to use the AC method because there's a number in front of the m squared. We multiply the 25 times the 4. That gives me a positive 100. And look at the signs. It's positive. They're both going to be the same. The middle being negative means they're both going to have to be negatives. We're going to have two negative numbers. They're going to multiply to 100, and they're going to add to 20. And if I think about numbers that multiply to 100, 1 and 100, there are a lot of them. 2 and 50, 4 and 25, 5 and 20, 10 and 10. I think that's pretty much all of them. And the only ones that I see that add up to 20, remember this is a plus here, so it has to add to 20, will be the 10 and the 10. So I'm going to rewrite this as 25m squared minus 10m and minus 10m. In other words, I broke up the negative 20m into two negative 10m. M plus 4. Remember, I bring down the number that was originally there. And here is my group. In my first group, 25 and 10 has a common factor of 5. M squared and m has a common factor of m. So 5m into 25m squared will give me 5m. And 5 into negative 10 will give me negative 2. And the m's cancel out. In my second group, I have negative 10m plus 4. And the common factor there happens to be 2, except since this middle term is negative, I have to include the negative as part of the common factor. In other words, I'm going to factor out a negative 2. Whenever my group or anything that I'm trying to find the common factor of starts with a negative, that negative becomes part of the common factor. So negative 2 into negative 10m is positive 5m. And negative 2 into positive 4 is negative 2. And now I see that my common binomial factor is 5m minus 2. And the other factor that's outside, the two outside numbers, is also 5m minus 2. These two binomials are identical, so we could have written this as 5m minus 2 squared. It's not wrong to write it this way, but this is a more succinct and probably the way you would see it on a test as part of a multiple choice answer. They mean the same thing. Notice, if you look back at it, when you have a binomial squared like 5m minus 2 squared, the first term of your trinomial was the 5m squared, 5m times 5m, which was 25m squared. The last term squared, negative 2 times negative 2, gave you the positive 4. Where does this negative 20m come from? If you multiply these two numbers together, the 5m times the negative 2, the two numbers of the binomial, that gives you negative 10m. You have to have two of them because one would be outer and one would be inner. So 2 times negative 10m, that gives you the negative 20m. But you don't have to know that. You could just factor it as regular, and then, but remember, you can write it as a binomial squared. Any questions so far? Okay, so let's go on to the next example, which is number 25. Where we have $12x to the third minus 10x squared minus 12x. And again, we want to factor this completely. And again, the first thing we look for is a common factor. Now we have a 12, a 10, and a 12. So the one number that goes into all of those is going to be 2. Then I have an x third, x squared, and x. They all have x terms, so 2x is my common factor. Now I divide out the 2x into each term. 2 into 12 is 6. X into x third is x squared. Then we have 2 into negative 5 is negative 2 into negative 10 is negative 5. X into x squared is x. And finally, 2 into negative 12 is negative 6, and the x's cancel out. And I'm left with my trinomial of 6x squared minus 5x minus 6 inside my parentheses. Now that's a trinomial. It's possible it could be factored further. We're not sure. Not always can we factor a trinomial or anything, but we usually try. Now, if I want to factor 6x squared minus 5x minus 6, forget about this 2x on the outside for the minute, I'm going to have to use the AC method because there's a number in front of the x squared. So I'm going to multiply the 6 times the negative 6, which is going to give me a negative 36. And therefore, I'm looking for two numbers that multiply to 36. And since this is negative, they have to subtract to 5. Now, let's see what multiplies to 36. 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. And the ones that subtract to 5 are the 4 and the 9. So we're going to have to break this negative 5x into two numbers. And since the 5 is negative, it's going to have to be a plus 4x and a negative 9x. I'm just taking, and this I'm leaving my 6x squared. And this I'm leaving my negative 6, and I'm going to do grouping here. So between 6x squared and 4x, my common factor is 2x. And I will get 3x plus 2 in my parentheses. Between negative 9x and negative 6, my common factor is negative 3. Remember, there's a negative here, so we have to include that as my common factor. Negative 3 into negative 9x is positive 3x. Negative 3 into negative 6 is positive 2. So this becomes 3x plus 2 as in one parentheses, because that's what's in our two parentheses. And then the outside is the 2x minus 3. Don't forget there was this 2x from before. So this is the complete factorization of number 25. Any questions about that? Okay, so those were the factoring questions. The other questions on this page are quadratic equations. Remember, a quadratic equation is an equation in which you have an x squared, or whatever your variable is, you have an exponent of 2. We learned at the beginning of the term what we called linear equations or first degree equations. There were no exponents. Now we're dealing with equations that have exponents, and I'm going to go through all of those questions as well because it's just a very important topic. I would say one of the most important things that you're going to learn this term is quadratic equations and how to deal with them. This is just the beginning of that topic. Later in the term, we're going to deal with those that can't be solved by factoring. We are doing the ones that can be solved by factoring now. Okay, so number 30 looked like this. It's 4x squared plus 12x equals 0. If you recall the steps involved in solving a quadratic equation, which I recognize because I see this x squared, I have to bring everything to one side of the equation and equaling 0 on the other side, which I already have in this case, and then you factor it. You factor it completely as much as you possibly can factor it. So as before, I look for a common factor, and there is one. It's 4 in both of them and x. So I put the 4x on the outside, and on the inside, 4 into 4 cancels. X into x squared gives me x. Then the next term, 4 into 12 gives me positive 3. The x's cancel out. Sometimes they already give you the thing factored. If you are given the question in this format, you have saved yourself a step. They've done the factoring for you. But that only works if the number on the other side is equal to 0. If it's equal to anything else, then you have to get rid of the parentheses and bring everything to one side and then factor, because the whole method depends on two things being multiplied and equaling 0, which is what we have now. What we do is we separate our two factors, the two things that we're multiplying. So one factor is the 4x, and we set that equal to 0. And the other factor is the x plus 3, and we set it equal to 0. Remember, we said that because the only time you can get two numbers to multiply to 0 is that one of them has to be 0. We don't know which one is the 0, but it could either be the 4x or it could be the x plus 3. And this gives us two answers. I solved this by dividing both sides by 4, and this gives me x. Well, 0 divided by anything is 0. And this I get by subtracting 3 from both sides, and this gives me x equals -3. And here are my two answers, 0 and -3. Sometimes you see them inside this brackets. So that's the general method of solving a quadratic equation. Okay, let's go on to number 31. I'm going to erase this. Again, if you want me to stop, or if you want to have a question, make sure you stop me. Number 31 looks like this. We have x squared plus 12x plus 20 equaling 0. And we want to solve, again, this is a quadratic equation. It says solve, but I would know, even if it didn't say solve, that it's a quadratic equation. First of all, it has an x squared and it has an equal sign. It's an equation. It's not just an expression, it's an equation that has an equal in it. We want to solve this again. It's a quadratic equation, so it has to be equal to 0, which it is. So then we're going to try and factor it. And this is an easier type of factoring because my leading coefficient is 1. If my terms are not in the standard order of the square, then the x, then the number, I have to move things around so I have things in the standard format so I can factor it. The x squared I break up into x and x. Again, I look at my last term, it's positive. That means both numbers are going to have the same sign. And since the middle term is positive, it means both of them have to be positive. And I'm looking for two numbers that multiply to 20, but when we add them, they give us 12. Well, that can only be 10 and 2. Okay, once we've got it factored, we separate the factors and we get x plus 10 equals 0 and x plus 2 equals 0. Over here, to solve this one, I bring 10 to the other side. I get x equals negative 10. And this one gives me x equals negative 2. I would say in 95% of the cases, you get two different answers for your quadratic equation. You don't get just one answer, you get two. Sometimes the two parentheses turn out to be identical, and therefore you only get one answer. There are really two answers of the same number, so it's one answer. But this again gave us two answers, negative 10 and negative 2. Okay, now let's looking at number 32. Number 32 gives me x squared minus x equals 30. And again, I see that this is a quadratic equation because of that x squared. And because it has an x squared in it, and I want to solve it, I want to get it equal to 0. So the first thing I'm going to do is bring the 30 to the other side of the equation. So I will have it equal to 0. So I have x squared minus x and minus 30. These are not like terms, so I can't combine them, but I'm putting them in the standard order. And now I'm going to try and factor. So the x squared I break into x, and I look at my last term as negative, means one number is going to be positive, one number is going to be negative. And I need numbers that multiply to 30, but when I subtract them, they're going to equal, remember, this is as understood to be a 1. Well, numbers that multiply to 30, but subtract to 1 are 5 and 6. And since the middle term is negative, the larger number, the 6, is going to go with a negative, and the 5 is going to go with a plus. And again, I separately set them each equal to 0. So I get x plus 5 equals 0, which gives me x equals negative 5. And then the x minus 6 equal to 0. And I get 6 to both sides. And I get x equal to 6. So here are my two answers, negative 5 and positive 6. That was question number 32. Okay, any question about this so far? Okay, so let's look at number 33. You know what, let's skip number 33 and let's just go on to 34. I think 33 is, I think you could probably do it on your own. If anybody has any question, you can ask me after class. Number 34 looks like this. It's 3x squared minus 75 equals 0. Okay, again, quadratic equation because it has an x squared. And it's already equal to 0. So we're up to factoring. First of all, I look for a common factor, and there actually is a common factor of 3. So this becomes 3 times x squared, and 75 divided by 3 is 25. And I'm left with this x squared minus 25 to factor. And since this is a binomial, the only way I could possibly factor it would be the difference of squares. But it is, because this is an x times an x, and this is a 5 times a 5, and there's a minus in between it. So this becomes x plus 5 in one parentheses, and x minus 5 in our other parentheses. Remember this 3 from before. These are conjugate binomials. They always, when we multiply conjugate binomials, we get the difference of squares. We don't get a trinomial, we only get a binomial. And again, we're going to do what we did before. We're going to set our factors equal to 0. Now, there actually are 3 factors, 3 things being multiplied. There's a 3, an x plus 5, and an x minus 5. And any one of these 3 could equal 0, and that would make the whole expression 0. But if I think about it, the first factor, the 3, can never be equal to 0. It doesn't have any x in it. It doesn't have any variable. It's just a plain 3. The only thing plain 3 can equal is plain 3. It can never equal 0. 3 does not equal 0. So I can ignore that 3. It can never be equal to 0. But the x plus 5 could be equal to 0. And the x minus 5 could be equal to 0. Either one of those could be equal to 0. In this case, this will give me x equal negative 5. And this will give us x equal plus 5. So our 2 answers are negative 5 and 5. Sometimes also written this way, as I mentioned before, plus or minus 5. This is a quick way of writing a positive 5 and a negative 5 if you don't want to repeat writing the 5 twice. Okay, that was question number 34. Okay, we're up to question number 35. Where it says we have 4x squared minus 9x plus 2 equals 0. Again, we see this is a quadratic equation because it has an x squared in it. And we know it has to be equal to 0, but it already is. So our next step is to factor. But this, the first thing we look for is a common factor, and there isn't any. And since I have a leading coefficient of 4, I'm going to have to use the AC method. I'm going to have to multiply the 4 times the 2. That's going to give me plus 8. That's what AC is equal to. Now, since it's positive, it means that we're going to be multiplying numbers and they're going to give me a positive answer. It means both signs have to be the same. And since the middle sign is negative, it means both numbers are going to have to be negative. And I want to find 2 numbers. When I multiply them, they give me 8. But when I add them, they give me 9. And obviously that's 1 and 8. So when I rewrite this, this is going to be 4x squared minus 1x minus 8x plus 2. I've broken up the negative 9x into negative 1x and negative 8x, so I can do my grouping. In my first group, my common factor is x, and I get 4x minus 1 in that first parentheses. In my second group, I have an 8 and a 2, so my common factor is 2, but since it starts with a negative, the common factor has to be negative 2. And negative 2 into negative 8 is positive 4x, and negative 2 into positive 2 gives me negative 1. So that when I finish factoring this, my first parentheses is going to be 4x minus 1. And my second one is going to be, let's get this out of the way because it looks like a 1. My second parenthesis is going to be the x and the minus 2. Okay, now we factor. Now we can set each of these factors equal to 0. So we will get 4x minus 1 equaling to 0, and x minus 2 equaling to 0. Now solving this, I have to add 1 to both sides. So that'll give me 4x equals 1. And to get what x is, I have to divide by 4. So one answer is going to be 1/4. Here I'm going to add 2 to both sides. And this will give me x equal 2. So my second answer is 2. So my answers are 1/4 and 2. That's the solution to this example. What makes this a harder example is the fact that the factoring is harder. But if you notice, it is, as long as you know how to factor, you can solve this equation. Okay? So let's look at number 36. Number 36 looks like this. 2x squared equals x plus 1. And we see this again, that this is a quadratic equation because we see that x squared in it. But it doesn't equal 0, so the first thing I'm going to have to do is set it equal to 0. And since the 2x squared is positive, we always want our x squared term to be positive. I'm going to leave it where it is and bring everything to that side. I will bring everything to the side. I bring it to the side that will make the x squared a positive term. So I'm going to bring the x from, get the x away from here. So I'm going to subtract x from both sides. And I also want to get rid of this 1, so I'm going to subtract 1 from both sides. So that I'll be left with 2x squared minus x minus 1 equaling 0. And now I'm going to try and factor this. And again, I see there's no common factor, and I have a leading coefficient of 2. So I'm going to have to use the AC method. I'm going to multiply the 2 times the -1, which will give me -2. Which means I'm going to have to look for 2 numbers that multiply to -2, which means one's going to have to be positive and one's going to have to be negative. And they're going to have to subtract 2, 1, because the number in front of the x not stated is a 1. So the only numbers that multiply to 2 are 2 and 1. And in this case, it will be the 1 that's the positive and the 2 that's negative, because that middle term is negative. The larger number has to be negative. So rewriting this, this becomes 2x squared plus 1x minus 2x minus 1. Again, I'm going to split it. In my first group, my common factor is x, so this becomes x times 2x plus 1. In my second group, my common factor, there's no common factor except that it starts with a negative. My common factor is -1. So -2 divided by -1 is positive, that's positive 2x, and -1 divided by -1 is positive 1. So that this factors into 2x plus 1 times, now what's in the second parentheses is the x and the -1. And now I separate them each into, and set them each equal to 0. 2x plus 1 equals 0, and x minus 1 equals 0. Here I'm going to subtract 1 from both sides, which will give me 2x equals -1. I'll divide by 2. So one answer is, let's put the answers over here. So one answer is -1/2. And here I'm going to add 1 to both sides, and that'll give me x equal to 1. So here are my two answers, -1/2 and +1. Again, quite a bit of work, but just follow through and they'll work out. Okay, there were 2 questions left, 37 and 38. Let's go through those. I hope this is getting boring for you, because if it's getting boring, it means that you understand what's going on. If you notice, they're so similar. The steps are all the same. Okay, now number 37 is 5x squared plus 4x plus 12 equaling 2x plus 12. And again, I notice that's a quadratic equation because it has an x squared, which means the first thing I have to do is get everything to one side equaling 0. So I'm going to, since this has the x squared term being positive, I'm going to bring everything to the left side. So I'm going to subtract 2x from both sides. And I'm also going to subtract 12 from both sides. So then I'm left with 5x squared. Now the 4x minus 2x is minus 2x. And the positive 12 and negative 12 cancel out. So, and this all canceled out. I'm left with, after I've brought everything to one side, with 5x squared minus 2x. It's only 2 terms, but again, I want to factor it. And the first thing I look for is a common factor. 5 and 2, there's no number, but x squared and x means x is our common factor. And x into 5x squared is 5x. And x into negative 2x is negative 2. And now I separate them, and I set one factor, x equal to 0. So one answer is x equals to 0. The other answer we get by setting 5x minus 2 equal to 0. And I solve that. I bring 2 to both sides. I get 5x equals 2. And my other answer, here's my answer, 0 and 2/5. Actually, this one that looked so much harder than a lot of the others turned out to be less work because the factoring was simple. The last question on this group, number 38. Number 38 looks like this. 5x squared plus 2x minus 4 equals 2x squared plus 2x plus 8. Again, this is a quadratic equation because I see x squareds and I want to bring everything to one side. So first of all, I'm going to subtract 2x squared from both sides. I want to get everything equal to 0. I'm going to subtract 2x from both sides. And I'm going to subtract 8 from both sides. Let's see what happens. That'll give us 0 over here. Okay, so now we have 5x squared minus 2x squared, which is 3x squared. Positive 2x and negative 2x just cancel out. And negative 4 and negative 8 gives me negative 12. So this simplifies to 3x squared minus 12. And now I want a factor, and I see a common factor of 3. this becomes 3 times x squared minus 4. And x squared minus 4, again, is our difference of squares. That factors to my two binomials, x plus 2 and x minus 2. And again, just like before, we have these 3 factors, but the 3 can't be equal to 0, so we just do x plus 2 equal to 0 and x minus 2 equal to 0. So one answer gives me x equals negative 2, and the other answer is x equals positive 2. We get 2 answers, negative 2 and 2. So again, the steps are the same. Bring everything to one side, factor, and then set your factors equal to 0. In other words, it's not enough to factor it. Since it has it equal to 0, since it's an equation, you have to go the further steps to get to the final value of the x. Okay, now here's what I'm going to do. As I said, since we're going to be having a Delta math test on, I'm going to open it up on Thursday after class. I want to do some review of the topics that you might find on that. And so I'm going to put a couple of questions on the board that I'm going to let you do. And I'm going to remind you that the topics that we've learned so far are systems of equations that are going to be on this test, are systems of equations and polynomials, adding, subtracting, and multiplying polynomials, factoring polynomials, and solving quadratic equations. Those are the topics that are going to be on the next Delta math quiz. As well, there's going to be, once we finish the total review for the midterm, I'm going to give you a test on all the topics of the midterm and as a prep for the midterm itself. Does anybody have any questions? I'm going to put some examples on the board, and then I'm going to take attendance, and we're going to go over those examples. Okay, so I'd like you to work on these examples. Okay. Here are some system of equations examples. There are 3 system of equation examples that I want you to do. I want you to solve x plus 6y equals negative 35, and x equals y minus 14. That's going to be 1. This is going to be, you're going to write these down because I'm going to have to erase them when I start working on them. The second system of equations I want you to solve is negative 7x plus 7y equals negative 49, and 3x minus 5y equals 21. And the third, I'm going to have time for here's the third question. We have tickets to a movie that cost, listen to the question because I don't want to write the whole thing down. $5 for adults and $3 for children. We have two types of tickets, and we sold 150 tickets for a total of $610. And we want to know how many adult tickets and how many children's tickets were sold. Okay, so while you're doing these three problems, and if you get the answer, you can put them on the chat. I'm going to be taking attendance. Ray Adams. Ray,
I'm here, ma'am.
okay, were you here on the 24th? I have you.
That was 2 weeks ago on Thursday.
Yeah.
No, I wasn't here that day.
Okay.
I had to get my wisdom tooth taken out that day.
Okay, I hope you're okay now.
Nah, I'm okay. Don't worry about it. Thank you.
Lukey here?
Yeah, I'm here.
Farhans.
Hi, I'm here.
Good. Justin.
Here.
Good. Jordan Calendar.
Yeah.
Good. Halima, are you here? Kaimani.
I'm here.
Good. Shanice, I saw you here. Carmelita, I saw you here. Monette Daniels. Darren, I see you sent me a note. Cheyenne Duncan, I saw you here, I'm pretty sure. Tiamani Ferran.
Tiamani, and I'm here.
Tiamani. Okay, good. I'm glad you're here. Stephanie Fuentes.
I'm here.
Oh, good. Tyler Graham. Tyler here? Tyler? Tashawn here? Ariel? Hoda, I saw you were here. Caesar Hicks? Diamond, I saw you were here. Zanaya Zanaya Jenkins? Okay, good, great. Eureka Jules. Jefferson?
I'm here.
Good. Kylie. Kai here? Teresa Lindsay?
Here.
Good. Partana Nath? Faria? Isosa Odemwingie? Jennifer Passio? Theater? Amy Sandoval?
I'm here.
Oh, good. Evelyn Solo?
I'm here.
Good. Cheyenne Short?
I'm here.
Okay, good. Aisha Silla?
Here.
Good.
I'm here.
Donasia Sirleaf? Daryl Stewart? Camille White? Camille? Martin Williams? Martin?
I'm here.
Okay, good. Nikisha Williams?
I'm here.
Good. Marcus Williamson?
I'm here.
Good. Snapfar?
I'm here, Professor.
Good. And Joel?
Here.
No, I called you Joel, it's Yoel. Sorry. Good, I'm glad you're here. Okay, I'm still giving you a little time to work on those problems. I see some people have gotten, but work on all three of them and then we'll get the answers together. turn on the recording again. Okay, so these are what we call systems of equations, where we have two variables and we want to solve for the value of each variable. And this first equation that says x plus 6y equals negative 35 and x equals y minus 14, to me, you could use the elimination method because you could bring this y to the other side. But since the second equation tells me that x equals y minus 14, it looks like a good setup for substitution. In my first equation where I see the x, I'm going to replace it with y minus 14. I'm substituting y minus 14 for x. They are equal. That means they're the same thing and can be used interchangeably. So my first equation becomes x, which is y minus 14, plus 6y equals negative 35. Combine the like terms over here, y and 6y gives me 7y minus 14 equals negative 35. And I'll add 14 to both sides, which will give me that 7y, here the 14's cancel out, negative 35 plus 14 is negative 21. And since we have 7y equals negative 21, if I'll divide both sides by 7, I'll get y equal to negative 3. And then I can go back to this equation, which tells me that x equals y, which I now know is negative 3 minus 14. And negative 3 and negative 14 gives me negative 17. So your solution is x is negative 17, y is negative 3. And you could write it separately like this, that's acceptable, or you can write it as an ordered pair. But if you're writing it as an ordered pair, make sure that you put the x value first and the y value second. You can always check these, and you can always, don't forget, you're allowed to use a not a graphing, but a regular scientific calculator, not a graphing calculator, but a scientific calculator that will help you with these. Okay, so that was question number 1. Does anybody have any question about that? Okay, so let's try number 2. I'm going to erase this and move number 2 up there. Okay, so we have negative 7x plus 7y equals negative 49. And 3x minus 5y equals 21. I'm now erasing this so I have room for it. And this, each of these equations are what we call standard form, which means that we have the x's and the y's and they equal a number. And they're set up, so I think I'm going to use the elimination method on this one. Again, even you can use whatever method you want, because even if it says do it by substitution, if all it's asking for is an answer, then you could do it by whichever method you want. So let's say decide I want to get rid of the x's here. So if I want to get rid of the x's here using the elimination method, I'll multiply the top equation by 3 and the bottom equation by 7. Remember, I just use the numbers first. I worry about the sign second. I also think about the signs. Since the top one is negative and the bottom one is positive, I have a good setup because I want one of the numbers, one of them to turn out to be positive and one to turn out to be negative. So I'm not going to use any negatives when I multiply because I want to leave the signs the way they are. Multiplying the top by 3, I'm going to get negative 21x plus 21y equals, okay, here's my calculator because I don't like to do these. I don't know if negative 49 times 3 in my head. That gives me negative 147. The bottom equation, when I multiply by 3, is going to give me positive, I'm multiplying that one by 7. So 7 times 3x is 21x. 7 times negative 5y is negative 35y. And 7 times 21 is 147. Now I add these together. Negative 21x plus 21x cancel. 21y minus 35y is negative 14y. And negative 147 and positive 147 give me 0. And when I divide both sides by negative 14, I get, well, 0 divided by anything is 0. So my answer for y is 0. Now I have to figure out what the x is. So let's go back to, it doesn't matter which one I take, the top one. Negative 7x plus 7 times 0, because that's what y is, equals negative 49. And that leaves me negative 7x equal, the 7 times 0 is just 0, so we don't have to put that in. Negative 7x equals negative 49. And that gives me x equals positive 7. So my solution is x is 7, y is 0 as the solution for this system of equation. Any question? Okay, that being the case, so then let's look at the last question. Okay, I'm going to erase number 2 so that I can work on number 3 on the top here. How many people were able to do at least one of those questions? Just put it in the chat. Just let me know if you were able to do those. Okay, nobody was able to, I saw some people had answers. Okay, great. I see at least 2 people. More than that should be able to do these examples. Okay. All right. Now this one is a word problem where we're going to have to set up a system of equations and solve it. Now we were told there were 2 types of tickets, adult tickets and children's tickets. Let's call them, let's call the adult tickets A and the children's tickets C. You could have called them X and Y as well. What do we know about them? First of all, a total of 150 tickets were sold. That means A plus C has to equal 150 because they sold adult tickets and children's tickets. Together, a total means add, a total were sold for so we had 150 tickets sold. This has nothing to do with the price of the tickets or just how many there were. The next thing we know is that they got $610 for selling these tickets. Well, obviously that not only means how many they sold, but how they got for each ticket. So therefore, the next equation has to do with money. So let's look at that. The amount of money they got for the adult tickets is 5A. In other words, if they sold 100 adult tickets, they got $500 because not only how many did you sell of each kind, but you have to include the price. The amount of money they got for children's tickets is 3C. And that's our 610. So here is your system of equations where you have two variables and two unknowns. You should be able to have set up this system of equations. Now to solve it, they want us to find A and C. So let's say we decide we want to get rid of the C first. So if we want to get rid of the C, I'm going to multiply the top equation by 3 and the bottom equation by 1, or just not multiply it at all. But since these are both positive and I need one to be positive and one to be negative, I'm going to put a negative by one of them. It doesn't matter which one you put the negative with. Just one of the multipliers, one of the numbers you're multiplying has to be negative. If we do it this way, we're going to get 3A plus 3C equals 3 times 150. Don't forget to multiply both sides by the 3 is 450. And the bottom equation becomes negative 5A minus 3C equals negative 610. When we add these two equations down, 3A and negative 5A gives me negative 2A. 3A and negative 3A cancel out. 450 and negative 110 gives me negative 1. Let me not guess on this. Do this on my calculator. Negative 160. And dividing both sides by negative 2, I get A equals negative 160 minus 2 divided by negative 2, which is positive 80. A, remember, A stands for how many adult tickets were sold. 80 adult tickets were sold. To find out how many children tickets were sold, well, let's substitute the A over here. So 80 plus C equals 150. And if I subtract 80 from both sides, I'll get C equals 70. So 70 children's tickets were sold. So that's the solution to this system of equations. We set up the system of equations and we solve this. You should be able to do something of this nature as well. Okay, good, Carmelita, great. I'm glad to see some of you are getting these answers. Okay, we still have a few minutes, so let's just quickly review. The other thing that we learned, aside from systems equations, is the polynomials. Now, today we spent a lot of time reviewing and doing examples that had factoring in them. So that's one part of it, but let's just do an example that has either an addition or a subtraction in it, and let's do an example that has a multiplication in it as a review. Remember, your test will be on Delta. This test is also going to be on Delta Math, and it's going to be available on Thursday after class, and you will have until Friday evening to complete it. So let's look at an example like this. I'm going to put two examples on the board again. So first of all, now let's put three examples on the board. First of all, perform the given operation. See if you can do this. 4x to the 8 minus 5x to the 7th plus 5x to the 6th plus 7 minus parentheses 9x to the 8th minus 2x to the 7th minus 8x to the 6th plus 8. That's one question. Here's another question I'd like you to do. Multiply this. X squared plus 9 times x minus 3 times x plus 4. Let's see if you can do that multiplication. And all right. And we probably won't have time to do more than that, so I'll just do those two. Okay, I'll give you a few minutes. I'll give you 5 minutes to try those two. But I'd like to finish these before class is over, so let's do these together if we haven't finished them. First of all, the first one is the subtraction. Notice you're subtracting the second parentheses from the first. We are subtracting 9x8 minus 2x7 plus 8x6 plus 8 from the 4x8 minus 5x7 minus plus 5x6 plus 7. Remember, when you have a minus in front of a parentheses, it's if there's a minus, you're multiplying everything in your second parentheses by -1. So you're really going to get 4x8 minus 5x7 plus 5x6 plus 7. Now we're multiplying each of these by -1 minus 9x to the 8th plus 2x to the 7th plus 8x to the 6th and minus 8. Remember, when you're multiplying by a -1, you're changing the signs. And now we're going to combine the like terms. The 4x8 and the negative 9x8 is going to give me minus 5x to the 8th. The negative 5x to the 7th and the plus 2x to the 7th is going to give me negative 3x to the 7th. The positive 5x to the 6th and the positive 8x to the 6th together will give me 13x to the 6th. And the 7 and the negative 8 will give me -1. I just combine all the like terms. All you have to do is be careful. There's nothing very difficult about that. About here, where we actually are multiplying 3 binomials. Now, you can't multiply 3 things at once. You have to do it 2 and 2. So what you're going to do is first multiply the x squared plus 9 times the x minus 3. Now you could have, if you wanted to, have done the x3 minus times the x plus 4. It doesn't matter. You just have to take 2 of them and multiply them together. And once you have that answer, you're going to multiply it by the third. I'm going to do it in the order it comes. So I'm just multiplying x squared plus 9 times x minus 3. So x squared times x will give me x to the third. X squared, this is binomial, so I'm really using FOIL. Outer is x times negative x squared times minus 3, which will give me negative 3x squared. Inner will give me plus 9 times positive 9 times x, which is going to give me plus 9x. And finally, last, 9 times negative 3 is minus 27. None of these are like terms. Usually we do have like terms, but there are no like terms. But we have to multiply this by x plus 4. which means I'm going to take each of the terms in this first parentheses and multiply first by x, then go back and multiply them by the 4. So first multiplying now it's not FOIL because it's not binomials, but it's still each term in the first parentheses times each term in the second parentheses. X to the third times x will give me x to the fourth. X to the third times 4 is 4x to the third. Next, negative 3x squared times x is negative 3x to the fourth. Remember, when you're multiplying, to the fourth, x cubed. When you're multiplying, you're adding their exponents, and this has an exponent of 2, and this is 1, so that gives me 3. And then the negative 3x times the 4 is negative 12x squared. Now we're on to the 9x. 9x times x is 9x to the second, 9x squared. 9x times 4 is 36x. Finally, negative 27 times x is minus 27x. And negative 27 times 4, now that I don't know in my head, so I'm going to take out my calculator. Remember, you're allowed to use a calculator. 27 times 4 is minus 108. So now I've multiplied everything in my first parentheses by everything in the second parentheses. Now let's see what we can combine. There's an x to the fourth. Now there's a 4x cubed and a negative 3x cubed. So that gives me a plus 1x to the third. Now we have a negative 12x squared and a positive 9x squared. That gives me negative 3x squared. And finally, we have 36x minus 27x is plus 9x and minus 108. In this case, we ended up with something that had 5 terms in it. You never know what you're going to end up with. Sometimes different terms cancel out, but nothing canceled out over here, and we were left with this polynomial. Any question about that? Okay, great. Okay, I see a bunch of, okay, so I hope everybody's clear on what's going on next. We will start with chapter 5 on Thursday. Don't forget to complete all the homeworks on Delta Math, and look out at Thursday afternoon. You have from Thursday afternoon to Friday evening to complete the test. It's going to be available Thursday afternoon. And we will spend some time also on Thursday reviewing chapters 1 and 2 so that we can have a pre-test for the midterm. Any questions? None. I'm going to end the session.